Welcome to our channel Easy Pharmacy. Today we will do the complexometric titration, and by using the different types of the standard that we say a secondary standard. From secondary standard we use EGTA, disodium EGTA, which used to form a chelate ring in with the metal ion. So for this we have taken here magnesium sulfate, and for neutralizing the reaction, as we used during the reaction, HCl has been used with a bromine water. To neutralize this reaction, we have to use the sodium hydroxide solution by making a solution. So for in this way, we would use the Eurochrome black tea as an indicator, and for the buffer we have to use the ammonium solution along with the ammonium chloride. You can see here. Now let's move toward the calculation part.
So now we'll talk about the calculation of this titration, that is we are talking about the complexometric titration of disodium EDTA with magnesium sulfate. Okay, so first we will prepare our primary standard, that is metal ions, that will be like here we are using magnesium sulfate. So we are considering the normality 0.005. so we are preparing, so it will be like preparation of 0.05 normal magnesium sulfate. Okay, so the formula will apply here. It will be weight equal to NEV, and V must be in liter. Okay, so the normality we are considering for our primary standard, that is MgSO4, it will be 0.005, and the equivalent weight of MgSO4 will be 120 into, and the volume we are dissolving this MgSO4, so it will be 100. So we are saying that the volume should be in liter, so it will be 100 divided by 1000, it will be 0.1. So the final value will be 0.60 gram. So what we have to do, we will take 0.60 gram of MgSO4 and we will dissolve in 100 ml of water, and this way we are preparing our primary standard. Now we will talk about our secondary standard preparation. So it will be like preparation of 0.05 normal disodium EDTA. So the formula will apply here, weight equal to NEV, and the normality we are considering here is 0.05, and the equivalent weight of disodium EDTA is 372 approximately, and the volume we are dissolving this disodium EDTA, it will be 100 ml. So volume must be in liter. So it will be the 100 divided by 1000, it will be 0.1. So the final value will be 1.86 gram. So what we have to do, we will take 1.86 gram of disodium EDTA and we will dissolve in 100 ml of water, and this way we are preparing our secondary standard. Now we will talk about the preparation of our indicator. So for the preparation of indicator, what we have to do, we will take so preparation of indicator we are seeing here. So preparation of indicator, so where indicator we are using Eurochrome black tea, so EBT here we are writing here. So what we have to do, we will take 0.5 gram of EBT and we will dissolve in 50 ml of 90% alcohol, and by this way we are preparing our indicator. Now the last step, we have to also prepare our base that we are neutralizing in this titration. So it will be the preparation of NaOH. So for the normality will be 2 normal of NaOH we are preparing. So it will be the preparation of 2 normal NaOH. So the formula will apply here, weight equal to NEV, and normality is a 2, equivalent weight of NaOH is 40, and the volume will be 100 ml. So 100 divided by 1000, it will be 0.1, so it will be like 8 gram. So by this way we are preparing our 2 normal NaOH. So this is all about the preparation of the reagent calculation. Now let's move on to the weighing of our reagents and the samples.
As we had already calculated about the magnesium sulfate, we have to take about 0.60 grams of magnesium sulfate. Try to measure it accurately and precisely in order to prevent and the as we had weighed, you can see accurately about 0.60 gram of magnesium sulfate. Now pour the sample into the beaker. Now let's move to the second reagent, let me say our disodium EDTA, which we have to take about point. Now try to measure. So disodium EDTA, as we had calculated earlier about 1.86 grams, we have to calculate very accurately. So we had weighed at about 1.86 gram of the disodium EDTA. Now pour it into a beaker, separate beaker. Now moving forward, we have to weigh ammonium chloride. So we have to weigh the ammonium chloride for making our buffer solution. So let's moving forward for making our buffer sample. For this we have to weigh about 5.4 grams of the ammonium chloride and dissolve it in a suitable solvent. Now we had weighed 5.40 grams of the ammonium chloride sample and close it after use. So after weighing this 5.40 gram of the ammonium chloride, put it into a separate beaker, clean and separate beaker. So let's move towards the formation of the weighing of the neutralizing agent. Our neutralizing agent, that is sodium hydroxide, in which we have to weigh about 8 gram of sodium hydroxide we have to weigh. So we had weighed our neutralizing agent about 8.0 gram of sodium hydroxide. Now let's move towards the weighing of Eurobrown black tea. Now weighed accurately about 0.50 gram of the Eurobrown black tea. Now pour it into a separate beaker for making a solution.
So now we will do the titration of the complexometric titration of disodium EDTA with the magnesium sulfate. So what we have do? So we have calculated our reagents and then we have weighed it and then make the sample according to the calculation and what we have done in the laboratories. So for the buffer, what we have do? We will take 5.4 gram of ammonium chloride and we will dissolve in 70 ml of ammonia and then we will make the volume up to 100 ml by using the water. Now what we have do? We have weigh our primary standard, that is magnesium sulfate, that is 0.60 gram. We will add HCl to it. Then we will add bromine water and we will boil to remove the excess bromine. Then what we have done, we will take the content after the boiling, after the content has been cooled. Now we will make the volume up to 100 ml or diluted by using the water. So after the has been diluted by using the volumetric flask, we will take the 20 ml of that content from the volumetric flask into the conical flask. Now we will add our NaOH to neutralize the content by using 2 normal NaOH and now make the volume up to like some dilution is there also in the content. Now after that we will add some ammonia buffer what we have that have been prepared earlier to dissolve the precipitate, and after that we will add our indicator, that is EBT, heliochrome black tea, and the color here has been produced, that is wine red. So earlier we have seen this, the magnesium sulfate and the indicator will react to form the color, that is wine red. When we are adding the EDTA from butyrate to the conical flask, the final color will be blue, because EDTA will react with MgSO4 to form the colorless solution, and when heliochrome black tea will be free, it will produce blue. So the final color will be blue. So the end point of this titration will be wine red to blue. So now we will add our secondary standard from the butyrate. So we are adding our EDTA from the butyrate to the conical flask, and you have to analyze the sharp color change. As you can see, color has been changed. You can see the color has been changed, and you can see the color is here blue. See this, the color has been changed from wine red to blue, and when you are doing the titration or adding the secondary standard from the butyrate, you have to constantly shake in the flask. So you should see here that the color has been changed, and this indicates the end point of this titration. So we will write down the reading. So here the reading is 12.5. Now we will take 3 reading for precise and the better result. And now let's move on to the calculation part. So after the titration we get the data. So we have taken 3 reading, and these are the data as you can see, the first one, second one, and the third one. So the first one is the initial reading, final reading, and the volume used by subtracting the final reading minus initial reading. So the data is here. Now we will calculate the total of the volume used, that is V minus U. We are indicating final reading and U indicating initial reading. So the total here will be 38, and now we will take the mean of it. Now we will take the mean of it. So mean equal to total divided by what we have taken, what observation we have taken. So we have taken 3, so it will be divided, so the value will be 12.66. So this is the volume used in this titration of EDTA with MgSO4. Now we will calculate the normality of our secondary standard, that is our disodium EDTA. So the formula will apply here, N1V1 equal to N2V2. This is a part of primary standard, and this is a part of secondary standard. So this is the N1 represent the normality of primary standard that we are considering, that will be given. V1 is the volume of MgSO4 we have taken in from the volumetric flask to the conical flask. N2 we have to calculate, that will be the normality of our disodium EDTA, and the V2 is here we are concluded or the calculated from the experimentally of the titration. So the modifying after the formula, it will be N1 V1 divided by V2. So it will be 0.05, that is our normality of our primary standard. V1 was 20 ml and V2 was, after the titration we are getting 12.66. So the final value will be 0.078 normal. So after the titration of the disodium EDTA with MgSO4 by using heliochrome black tea, we are getting the value or the normality of our disodium EDTA, that is 0.078. So this is all about the complexometric titration of disodium EDTA with MgSO4. So hope you like this video, share to your friends and relatives, and subscribe to our channel. Thank you so much guys for watching this.